Okay. All right, so the next problem here, they actually get a bunch, they get a lot easier right after this. Um, so we'll get back on track here with the lesson here shortly. So what is the solution to the graph system? Basically, they're asking, where do they intersect? What is the intersection point? And you can see it graphically. Now there's no scale, but you can presume that it's 1 unit each.
Yeah.
So going left and then up, which one of these is that point?
It's like -2, comma, +2. So it's
Exactly. You got it. Good. All right. Number 18. No problem here. All right. How many solutions are there to this system? So a solution occurs when there's an intersection. So another way to ask this is, how many intersections are there?
how many solutions? 2.
So there are 2 intersections. Where's the first intersection?
The first one is oh my god. Hold on. We had a problem one similar to this.
We did. And what I said here is that it really is asking, how many intersections are there?
Right.
So you said 2. So give me the first one. Where's the first place that they intersect?
It's the red line is one place that they intersect.
Okay. Try to ignore we're just looking at the blue and the red.
Yeah. I know
Where
there's
did
I know there's
where,
names for the little square parts. I just always forget them.
I'm gonna draw this over here off to the right
Okay.
without the grid. So I'm looking at something here where there's a red line, a lot of white space, a lot of white space, and a blue curve. These are sort of diverging from each other.
Yeah.
Help me out here. I don't see an intersection.
Oh. So there
This would be an intersection.
yeah.
Why
So
is that an intersection?
because the lines are crossing over each other.
Okay, so take a look at this back here on the left. How many intersections are there?
How many so that means there'd be none?
There are no places that they intersect.
Okay.
Now you saw something, and I mean that concerns me. You said that the red intersects twice. I'd like to know, I guess, what you thought it intersected. I have a feeling maybe you meant the x-axis and the y-axis.
Yeah, that's what I meant.
Okay. All right. So let's look at 20 next. We're skipping 19. We're going to come back to 19. We're going to 20 because it's similar to the one we just did.
Yeah, this time it is intersecting.
Yes. So what are the 2 ordered pairs where they intersect? And that also tells you A and D are out because those are only one set of ordered pairs.
All right. Okay, so I think the answer is C. Now, the reason I say that is because, well, number one, it's 2 different points because and um where the points intersect, it's at 4 comma 5, and it's the only one with a 4 in the answer. Well, I mean, so
Good.
yeah.
Good. All right. Last one here on this, number 19. All right. So this one may be a little awkward at first glance. You're like, what is going on here? Like there's an X here, a bunch of numbers and a bunch of numbers. The idea is that X is, it's not really X. Think of it as like a number here. Like I'll just put a 5 here for a moment. Okay. 5 times 2, 0, 3, -1, -2, 0 means to multiply each of these by that number.
Okay,
You remember us doing that in a previous lesson?
yeah,
Now, this is not the right answer, but it is the approach. Okay. So you're almost trying to figure out, well, how do you go from 2 to -6, 3 to -9, -2 to 6? What are you multiplying those by? It's like a working backwards problem.
you multiplying them by 2.
So 2 times 2 is -6. Is that what you
By
meant?
2 times -3.
Okay. Does that work for the next one? Does that work for this 3?
Yeah, it works for all of them.
There you go. There's your answer.
Let's see. All right, did it.
All right. So I'm going to grab the next lesson, which is determinants, lesson 34. So let me know when you're ready for us to move on to one for the next lesson.
Yeah, I'm ready.
Okay. All right. So it says to find the determinant of the following matrix going step. Now, the nice thing is that there is a formula for this, but constructor is not doing that. Okay. I guess they are doing, I guess they are doing it. Okay. The formula is the matrix is really composed of 4 elements, A, B, C, and D. And the determinant, DET stands for determinant of this matrix is A times D minus C times B. So if you notice, it's kind of a butterfly. You're multiplying diagonally like that.
Okay,
So here's how that looks in your problem. We're going to multiply 8 times -18. Subtract, we're going to go the other direction, 3 times 10.
okay.
So you'll have to grab a calculator and see what that comes out to.
That'd be -174.
Sounds correct. All right, good job. So we're going to do the same thing for number 2.
All right,
I'm going to leave everything up here and ask you to try it. It's exactly the same, just different numbers. Could you give that a try, please?
I got 5.
So 2 times 3
Oh, stop.
minus
Oh, wait.
minus 1 times 1. Is that what you have written? If not, take another look at that.
Ew, I see my mistake. Okay, I can fix that now. So it would actually be 7 instead of,
Yes. Yes.
oops.
All right. The next problem here is a 3 by 3 matrix. And it's the same thing. It's asking you to find the determinant. Unfortunately, it's a much different approach. And I actually do not like the way that they teach this. Although I think there's it'll be okay for what we're doing. So we're finding the determinants. It's totally a different approach, completely different approach than what we just did. So yeah, for if you ever see this again, you have to remember there's one approach for 2 by 2s, and then there's approach for what's called 3 by 3s. Okay, so I'm going to attempt to show you that here. The first thing that you do is you rewrite the columns, which doesn't make any sense the first time you say it, but you rewrite the first column. So it's gonna go, so you put it over to the right, 2, 2, and 1. Then you rewrite the second column, -3, 0, and 4. Okay, now this is where it gets a little bit confusing. I apologize. I don't know why they do it this way, but that's what they do. So you create your first diagonal going down this way, and you multiply those 3 numbers. 2 times 0 times 5, which equals 0.
Yeah.
Then you do the same thing for the next diagonal. -3 times -1 times 1 is 9. Then you do the same thing for the third diagonal. 1 times 2 times 4 is 8.
Okay.
All right. Next thing is to go in the other direction. You create a diagonal going this way. And same thing, you multiply 1 times 0 times 1. Then you do another diagonal. 4, sorry, this is 0. 4 times -1 times 2 is -8. Then you do your last one. 5 times 2 times -3 is -30. Is that okay so far?
Yeah.
All right, so here's the rule. The rule is you add the bottoms, you add the tops, and then you subtract. So for example, and I'll color code it here again, you would do 0 plus 9 plus 8. And then you add the top. The tops are 0 minus 8, 0, sorry, 0, 0 plus -8 plus -30, like that. So it's 17 minus -38, which equals 55. What do you think about that? Any feedback or any, do you think it's the worst thing in the world? It's not too bad.
It's interesting.
Yeah. Did I make a mistake? Sorry, I'm check. I never do them this way, so I gotta check this. All right, hang on. Let me look at the, okay. 2 minus 3, 1, 2, 0, minus 1, 1, 4, 5. All right, so I did make a mistake.
All right.
So give me a moment here. Where is the mistake? All right, let me see here. 0. Oh, there it is. So this is no, that's okay. -8, 15, 10, -30. Subtract. 38. Okay, 0. Oh, here's the mistake. This is 3. Sorry about that.
It's okay.
Very bad to make those mistakes. I'm working with a student who's doing a much more advanced course like this in college, and he routinely these things happen and they mess up the whole calculation. And it's better to do all of these in software, but when you learn them, you're supposed to do them by hand. But you can see it's so easy to make a little mistake there, and that does finish out the problem. So this is the correct answer. Right. So the next, you get another opportunity to try this out. We'll do it together. I know these are really difficult, like the first time you're seeing it, and it's a lot harder than just okay, we're going to multiply. It's there's a lot going on here. So, all right, find the determinant. We are showing the steps that they indicate in the lesson. So we'll do this again here. All right, so I'm gonna, again, you rewrite that first column. You rewrite that second column. And I'll color code it again. I like to do the bottom ones first. What color did I use? Yeah, blue. Okay. I like to go the bottom ones first. You can go the other direction if you want, but it's 1 times -1 times 1, which is -1.
Okay.
3 times -3 times 2 is -18. And the last one here is 2 times -3 times 3, which is also -18. Please double check those. Yeah, clearly I make mistakes and I don't I don't want a replication of that. So it looked okay. Now you go the other direction. You go bottom left to top right. 2 times -1 times 2 is -4. 3 times -3 times 1 is -9. And then 1 times -3 times 3 is also -9. And just like before, you have to add the bottoms. So -1 plus -18 plus -18. Then you subtract the tops, but you have to add them up first. So on the left here, it's -37 minus a -22. Looks like that becomes -15. I will again check this one because it's possible to make mistakes. And I know you get graded based on not just your work, but whether you got the right answer. So let's take a look here. That does look okay. When you break it down, it's really just a series of multiplications and additions and some subtractions. It's not like any one step is that difficult. It's just putting it all together, be able to replicate it.
Well, I'm ready for number 5, by the way.
I'm sorry, I didn't hear you.
I said I'm ready for the next problem.
Okay. So the next one requires you to find something. Well, how do I say this? It's a triangle. They're giving you the vertices of a triangle, and you could make a quick sketch. You could say, okay, here's the origin. There's a minus 3, 3. There's 0, minus 3, and then 1, 1. And you could actually calculate this using known formulas for area of base times height, but they want you to do it the way they do in example 4, which is some sort of matrix operation. Okay, so you would see this again in like vector calculus, but you're not there yet. So I don't know why they're having you do this, but the way this works is you just write the points in a column here like this. So I'm writing those 3 ordered pairs. And then you put the 1 right here.
Okay.
Okay, and I actually don't remember why it's a 1 here, but it doesn't really matter. So to find the area, you have to take the determinant, the determinant of this matrix. So basically you have to replicate exactly what we just did. And then there's a final little piece. So let's call this matrix A. The area of a triangle is the determinant of matrix A, but then it's really 1/2 of that.
Oh my god.
So unfortunately, back to doing the same thing here.
Back to
Um,
square one.
yeah, I'm going to grab it here. All right, so you rewrite the first 2 columns like that. Let me just double check that we got all the right numbers.
All right.
Okay, we all got them all. Okay, so why don't you try this one on your own, doing those multiplications,
God, I'll try.
do the best you can. That's all anyone can ask. So give me those 3 numbers when you've got them.
Okay, so I got 9, 3, and 0.
Middle one is -3 and the last one is 0. It's got a negative there.
Sorry.
It's okay. It's so easy to make just a little mistake here. Do the same thing for these 3, please.
All right, sure. Okay, -3, and 0.
Good. So again, it's the bottom numbers. You add up the bottom numbers and subtract the top numbers added together.
The answer would be +9.
Okay, so the first grouping is 6, right? And then it's minus a -6.
Oh, oops. I think I messed that up a little bit. Let's cross that out here. So it would actually be +12.
Positive 12, yes. All right, so the next one here, I'm going to make a quick sketch of it in Desmos graph. If you haven't graphed any points in a while, you just put them in as ordered pairs. And I'll snip that in so you can see it here in a moment. But I run out of room on this workspace to be able to show these nicely. All right, so zoom in a little. There we go. That's a little nicer. Okay. Yeah, so let me nip this in. All right, so you don't need to graph it, but visually it's a lot more useful to know like what are we doing when we graph it here. So I'm going to just connect these lines as best I can, or sorry, connect these points as best I can. You can see that this is a parallelogram. I think it says that in the problem. Yes. Okay. Now, if you draw a diagonal, if you draw a diagonal between two of the points that are non-consecutive, you get a triangle. And in the previous problem, we found the area of a triangle. Okay. So what you should notice is that you only need 3 of the 4 points to make a triangle. Okay. So in the last problem, we had 3 points. In the last problem, we had 3 points and we made a matrix, found its determinant. But remember how we cut it in half? And actually, we did not do that here. I mean, so we need to actually do that. Half of 12 is 6. That's your final answer for the previous one. So go ahead and make that adjustment.
All right. I just
Okay,
fixed
so
it.
the so the idea here is that it's the same problem as the previous one, except because you're finding a parallelogram, it's 2 triangles. So normally the area of the triangle is 1/2 the determinant of A. For a parallelogram, which is what we're doing in this problem, it's just the determinant of A. Because it's 2 of the triangles, 2 times 1/2, it goes away. So in short, you're just going to find the determinant of you're going to choose 3 of the 4 points to find the determinant. So we're going to use the first 3 points, I guess. I mean, it doesn't really matter, but we're going to use the first 3. It's -2 and 7, -4 and 4, -11 and 4, and then 1, 1, and 1. All right, so then you rewrite the the first column and you rewrite the second column. And just like we've been doing, you go diagonal. I think I've been going blue that way. I don't remember. Can I remember that? Okay, sorry, blue. So you got to do the same thing we've been doing here. You got to multiply diagonally, diagonally, and diagonally. So go ahead and give me those numbers, please.
All right. Would be -8, -77, and -16.
Okay, that looks good to me. So now we got to go the other direction. Do these 3 multiplications. The nice thing is there's a 1 in all of them, so it's really just multiplying 2 numbers.
Okay, now for the other ones I got -44, -8, and -28.
Good. Okay, so it's add up the bottom numbers, add them up to the bottom numbers first. It has to be this order. And then add up the top numbers. So go ahead and do that. I'm going to check this with another method just to make sure it's all synced up.
-21. That's what I got for my answer.
Yes, I agree. Okay. So we're done with those for now. And we're moving on to number D. It's more of the same, but it's I mean, sorry, it's a different style of problem, but it's still a determinant. Right? And like you already know how to do this. You already know how to write. Okay, here's 2 points. Let's write in slope intercept form. Problem is they want you to do it a certain way, saying like you must do it the way that we're showing you here. And the I'll just say it's awkward. It's really awkward. Um, just like before, you write the 2 points. Okay, but this time you put an X and a Y above them. And then a 1, 1, 1. And you're setting this matrix, excuse me, equal to 0. So this is the setup here. Is that okay for the moment?
Yeah.
All right, now, just like before, unfortunately, you have to take these numbers and we're finding the determinants. You have to rewrite the first column and the second column again. And if you aren't surprised, you're doing the same thing again here. This is 25x. This is 8y. And this is 244. So what you can start doing is just writing them down there. And then we'll go the other direction here. So this is 261x and 4y.
Okay.
All right, so you do bottom minus top. So you have this 25x plus 8y plus 244 minus 200 plus 61x plus 4y. This time it equals 0. The reason it equals 0 is if you go back and look, you have to set the setup here, you have to set it equal to 0. The determinant of this thing equals 0. All right. So you have to distribute the negative. Like this. And now you combine like terms. Do you see any, I'll let you get caught up here, but when you do, I want you to look for like terms.
So right now I have negative 36x plus 4y plus 44.
Very good. Okay, now we're almost there. It wants you to write it in, let's see what the instructor says here. I think it's a slope intercept form. Yes, okay, so that means we have to solve for y. So to do that, we're gonna move the 36x over to the other side of the equation and subtract the 44 to the other side of the equation. 4y equals 36x minus 44. And then you divide everything by 4. And look at there, it works out pretty nicely.
worked out really nicely.
So that's your final answer. That's what they're looking for there. Good news is you get to do another one, number 8. So it's rinse and repeat here. Notice that you write X, Y at the top and then the 2 ordered pairs, X, Y, and then the 2 ordered pairs. So we're gonna do the same thing here. We're gonna write X, Y, -8, -1, 0, -1, and then 1, 1, 1, like that. Just like the previous problem, we're going to rewrite the first column and then the second column. So if you could, I'd like you to do the diagonal multiplication here on the bottoms. Let me know what you come up with.
So I tried to do the multiplying by myself. So far, I've gotten -x, 0, and 8.
Good, that's correct.
Oh, yay.
Let's do the same thing for the other direction.
Okay, so then for that, it would be 0, -x, and -8y.
Good. So just like we've been doing, you take the bottom ones, you add them together, which is -x plus 8. And then you subtract the top ones there. -x minus 8y equals 0. On the left here, you don't need the parentheses. So you just get -x plus 8. You distribute the negative in here, so it's plus x plus 8y equals 0. Do you see any cancellations?
The x.
X's cancel, leaving you with 8 plus 8y equals 0. And so solving for y, you subtract 8 from both sides, divide by 8, and y equals -1.
Yep. All right.
All right, so just looking ahead here, it's gonna be pretty tight to finish tomorrow. We probably really close here, so we'll see how how that goes. Let me go and stop the recording here. There's 2 more lessons. I'm sorry, there's 1 more lesson, then a review assignment.